In our vllm code example, you might have noticed that although the LLM generates token one by one internally, the call to outputs llm.generate waits until the entire output is generated before running any result. And I showed you that in the previous video. In the context of a web service, for example, a chatbot, this means the user experiences a long delay before receiving any response, from a few seconds to even minutes, depending on the output length. Tokens are generated sequentially during the decoding phase. To improve responsiveness, you can return each token immediately as it is generated, which is a technique known as LLM streaming. Streaming in LLMs refers to the process of incrementally returning output token by token, or maybe in a small chunks during generation, rather than waiting for the entire output to complete. Now let's have a look how we can apply the streaming technique. This is the necessary library. For example, we need vllm and transformers. So streaming contains two steps: to return result when generation completes and return as soon as we have a token. The key difference in the streaming version of the vllm code is that we initialize the model using the async LLM engine instead of the standard LLM class. With async LLM engine class, the generate function returns a synchronous stream object that allows us to pull newly generated tokens one by one using an async for loop. This is the code. As you can see here, I'm importing the async engine args from vllm.engine.arg.utils, and I'm using also async LLM engine from the library vllm.engine.async_llm_engine. Here we are initializing the engine arguments. So the model here is Quinn, and the data type is a float 16, and the GPU memory utilization is 0.9, and other arguments you can set it. Then I'm creating the vllm async streaming engine. This is the most important thing that we are using here, the async LLM engine. Then this is the code to generate the text with the prompt and the max tokens and the request ID. As you can see here, to generate the text is async and the streaming fashion. As you can see here, by this engine, we will be using the async and streaming method. The final output to process the results. And here, the main function. So first of all, we are defining the input prompts. For example, the capital of Syria is. Then to generate a unique request ID. This is the best practice. I'm using the UUID library. And then to set a reasonable max tokens limit to be 120. Then to print the starting generation for a request ID and the prompt. Finally, to call the async generation function. And of course, we are using a wait here because this is async engine. As you can see, the results. So this is the request ID. The prompt is the capital of Syria is. And as you can see, it's chunk by chunk. Damascus, it is the largest city in the country and the second largest city in the Middle East. And the output will be stopped until it exceeded the max limit, which is 120. So generation completed successfully. So if we didn't set the limit, it will generate more and more, and this will take more computational resources. So this is best practice to set the limitation. So stop reason is the length and generated tokens 120. As you can see, the word chunk in your output refers to the partial segment of the text. I mean, one or more tokens that the vllm engine processed and sent back to your Python script during the text generation. This is the streaming behavior and is a direct result of how you designed your generate_text function. I want to mention that another valuable benefit of streaming is that it allows user to cancel generation midway if the output is heading in an undesirable direction. In vllm, this can be achieved by calling the engine.abort with the request ID, where request_ID is a unique identifier associated with the specific generation request. This feature not only improves the user experience by avoiding irrelevant or incorrect completions, it also helps conserve compute resources, which is especially important in production environments where efficiency and cost control are critical.